All right, folks, let's start. In this video here, we're going to talk about everything about quadratic functions, including how to use quadratic formula and also factorization to solve for the specific questions. Okay, let's jump to the first question. So our task is to solve the following equations by two different methods. First, apply one of the quadratic formulas and then use factorization. So we have quadratic formula, Okay, so the quadratic formula, if you guys are familiar with it, on the bottom is 2a and negative b plus or minus root b squared minus 4ac, assuming that the fact that we're dealing with ax squared plus bx plus c is equal to 0. Okay, so then we're going to use factorization. Okay, so the factorization, pretty straightforward. You're using the different coefficient to combine the coefficients over there. Okay, so the first question that we're dealing with is 6x squared plus 13x plus 6, which is equal to 0. So if we're using quadratic formula to do this question, so this is our first question, pretty straightforward. We're going to use 2 times 6, which is 2a, minus b, which is negative 13, plus or minus, the reason why it's plus or minus because that there are generally two roots. Root b squared, 13 squared, minus 4ac, in this case, times 6 times 6 again. Okay, so our answer for this one, if we do our calculation over here, would be equal to negative 13 plus or minus, underneath this will become 25 and then 12. Okay, and then it will be equal to negative 13 plus or minus 5 over 12. Once we simplified everything, the answer, the first answer will be negative 2 over 3. The next answer will be negative 3 over 2. So how do we use factorization for this question again? If we look at 6, if we look at 13 and we look at 6 again, so in our mind, we're combining the terms together. So what are the factors of 6? The factors of 6 is 2 and 3, right? What are the factors of 6 over here? 2, 3, negative 2, negative 3, or negative 3, negative 2. So we have to have different combinations in this case to make up to the 13. So let's try to factorize this question. So I'm assuming that, and I'm going to go with 2, 3 to start with, and then I'm also going to go with 2, 3 over here to start with. And let's see, if 2 times 3 and 3 times 2, 2 times 3 is 6, 3 times 2 is 6 again, 6 plus 6 is 12. It's not equal to 13, so this combination doesn't work. So let's try another combination. Let's try 2 and 3 first, but then 3 and 2, and let's see if we can get that. Oh, in this case, 3 times 3 is 9. 2 times 2 is equal to 4. So then 9 plus 4 is equal to 13. All right, I got my 13 for my coefficient, which is my b. So then how do I combine it? How do I put it into a factorization form or factor form? Is we use 2x plus 3. So this is my first term, 2x plus 3. And we multiplied it by 3x plus 2. That's my second factor. So 3x plus 2, which is equal to 0. And as you can see that if two terms multiply each other will become 0, so at least one of the term is equal to 0, which means that 2x plus 3 is going to be 0, which x is equal to negative 3 over 2. And also this one, 3x plus 2 is equal to 0, so which means that x is equal to negative 2 over 3. So hopefully this explains question number 1 and show you different methods to solve quadratic functions. The first method is also commonly used for method is called a quadratic formula. You can almost use all the questions using that. The second method is called factorization, in which you just have to know a little bit of knowledge in terms of factorizing the quadratic functions. Okay, so let's move on to another question. Okay, so express the following quadratic expression in factored form by using the quadratic formula as shown in an example. So again, we're going to use question we're going to change this question a little bit. So it's going to be 6x squared minus 13x plus 6. So the idea over here is that we can solve this question, no problem. So we will get two answers. For example, the last question, we get two answers, which is negative 2 over 3 and negative 3 over 2. So what can we do in terms of factorizing this formula or this equation by utilizing quadratic formula or the answers that we're getting? So first, what we need to do is definitely we need to get the answers, right? So using the quadratic formula again, 2 times 6, 13 over here, plus or minus 13 squared minus 4 times 6 times 6. We already know that underneath the radical sign will be 25, which will be 5 over here. So then if we get our answer, this will be 13 plus or minus root 25 over 12. And this would be 13 plus or minus 5 and over 12. So simplified everything, I will get x1 is equal to 3 over 2. x2 is equal to 2 over 3. So according to what we learned previously, right? How do we use the factorization form to get the answer? We know that, okay, so if I have the first answer, which is x1 is equal to 3 over 2, can I write it this way, x minus 3 over 2 as my first factor? The answer is yes, because when you substitute x1 equal to 3 over 2 in this equation, x minus 3 over 2, which is 3 over 2 minus 3 over 2, this will be equal to 0. So that makes sense. And then what I'm going to do is that I'm going to have the second one as well. So x minus 2 over 3. So once you have this in place, you want to ask, okay, my original function has 6 as the first degree coefficient. Again, what's the first degree coefficient? It means that the coefficient that's associated with the highest degree of the function. In this case is 2, right? So I need to multiply that too. And notice that if I multiply, this is what I have. This is what I had. If I multiply both sides by 6, will anything change? Absolutely not, because this is the equation. If I multiply the left side by 6 and also the right side by 6, nothing will change. So then this form becomes 6x minus 3 over 2, x minus 2 over 3 equal to 0 times 6 is also 0 as well. Then I have to be very strategic in this case because I had the 2 here and I had the 3 over here. So I have to associate 6 differently, right? So I will associate 2 to this term and I'll associate 3 to this term. And you might want to ask, Tony, why do I have to multiply this by the 6? So the official explanation is that because I have my first degree coefficient, which is 6, right here, if you guys can see, right? This is my target coefficient. I will need to multiply that by it to make it more realistic, to make it exactly like that when we open up everything. So that's the explanation there. So in this case, when I change everything, this will become 2x minus 3 over 2, and then 3x minus 2 over 3, which this will be equal to, when you multiply the 2 inside a bracket, this will be 2x minus 3, and then 3x if you multiply the 3 inside, 3x minus 2. How do I get the 2 and how do I get the 3? Come on, man. You know this from previous levels. The 2 will reduce with the bottom, the denominator, and the 3 will also reduce with the denominator as well. So this will be my final term, and I'm done. So I got this one from the answer that I got from the quadratic formula. And the question's goal is for me to get the answer first and then utilize this answer to get the factorization form. That's it. Okay, so we'll jump to another question here. Let's do a couple more exercise. Let's do 3x squared, number 3. We have 3x squared plus 7x minus 48. So first of all, again, we're going to use quadratic formula to get the answer. So the quadratic formula, 2 times 3, negative 7 here, plus or minus root 7 squared plus, because that's the negative over here, right? 4 times 3 times 48. Again, where does this 4 come from? This 4 comes from the formula, which is 4ac over here, right? So I am going to get the answer over here, which is 6, negative 7, plus or minus. This will be 49 plus 576. If I simplify it, everything down, this will be negative 7 plus or minus 25. So I'm assuming that inside this will be 625 here, right? So then this will be 6. I will get my answer as x equal to negative 16 over 3 and 3. So this is a very interesting question. So remember, our first degree coefficient is 3 in this case. So what should I do? Remember, I can use the answer I get from here, which should be x plus 16 over 3, and then x minus 3 equal to 0, right? Because if I substitute negative 16 over 3 into this one, I'll be getting 0. And if I substitute 3 into this one, the second term, I'll be getting 3. So in this case here, don't forget that we have to multiply the 3, right? But then 3 times 0 will be 0, so eliminate it. But when I associate this 3 inside a bracket, this will become 3x plus 16 and x minus 3. You might want to ask me, Tony, what happens with the second term over here? Don't I have to do something in the second term? Well, it's already looking quite simple, right? You just have to multiply the 3 from the first term. That just solves everything. So that's the whole goal over here. So let's move on. Okay, let's move on to the last. Okay, so let's move on to the last example over here. So given the quadratic equation, we have number 4 here. We have x squared plus bx plus c is equal to 0 if one of its roots is 1 plus root 2. So we know that one of the root is 1 plus root 2. Okay? Determine the value of b and c. So we're trying to get b and c. And the value of the other roots. So I also have to get the other roots. Okay, so what's my strategy here? What's my game plan over here? So assume that b, c are whole numbers. So b and c, they're whole numbers. Oh, that makes my life much easier. Okay, so, all right, so let's see. If I were to start this question, what I will be doing is that I have to substitute the 1 plus root 2 inside this whole equation. So this becomes 1 plus root 2 to the power of 2 plus b 1 plus root 2 plus c, which is equal to 0. And then after I open it up, you guys should know how to open this up already, right? So this would be 3 plus 2 root 2 and plus b plus root 2b plus c is equal to 0, okay? And then if I group up everything, what will happen over here is that I rearrange the term a little bit. If I have, so I have 3, I have the b, I have the c. And then I will group up the root 2 together as well. So this time it will become, and you might want to ask, Tony, why do I have to do that? Because the above equation will be true. If I group up everything, this will be 0 and this will be 0. Remember, b, c are whole number, right? And then 2 plus b times root 2 is equal to 0. So both of the terms have to be 0. So isn't it true that term 1 will be 0 and term 2 will also be 0? So this, again, we have to assume that, and that's a direction for us to kind of go for that route, right? So if that's the case, I would have a simultaneous linear equation, which is 3 plus b plus c equal to 0. And then I have 2 plus b equal to 0 as well. All right, in this case here, b, pretty obvious, is equal to negative 2. And then if b is equal to negative 2, then 3 minus 2 plus c is equal to 0, so which means that c is equal to negative 1. So I got my b equal to negative 2 and c equal to negative 1. So once I have b equal to negative 2, c equal to negative 1, I also have my a equal to 1. So I can rewrite my equation right here as x squared minus 2b, minus 2x plus 1. or minus 1. Okay, so again, up until here, we solved B and C. The idea of how to get the B and C comes from when I substitute one of the roots inside the formula, and I have to rearrange the term a little bit. And you might want to ask, hey, Tony, how do I rearrange the term so that I know that one term is equal to 0, another term is equal to 0? The brief answer is that you have to try the combination first, but you have to also take advantage of this crucial number, which is root 2. So you will have 2 root 2 and also root 2b. So how do I take advantage of this radical number? Is by associating the root 2 with the 2 and b. So then if I make that part on the side, I will have 3, b, and c on the other side. Your final goal is to create two parties that when they add together, they has to be 0. That has to be 0. So how do we do that? Is exactly how I showed you guys in this question. So the other questions, when we're doing it, we can simply try the same way as well. Okay, so I get this one, so it's pretty straightforward for you guys to find the answers as well. I can use a lot of methods to do it. I can use the quadratic formula to get the answer. I can also use the factorization to get the answer. In this case, I don't believe we can use factorization, but I'm pretty sure that we can use quadratic formula to get the answers as well. Okay, so that's basically summarizing these concepts of using quadratic formula and factorization, how do you use it interchangeably. You know what, let's do one more question. Yeah, let's do one more question so then we have a better understanding of this. So let's do one more. Question number 5. Okay, so we know that equation is x squared plus bx plus c is equal to 0. If one of the roots is -1 plus root 2, I need to get the value of b, value of c, and also I need to get the another roots. Okay, so how do I do that? Same thing. We substitute -1 plus root 2 into the equation. And let's open it up. In this case, let's see if we can combine everything together, just like what we did in the previous video here. So the first thing over here would be 3 minus 2 root 2. Okay, so that's basically from here. And minus b plus root 2b plus c equal to 0. So like I said before, right, what we can do is that we can take advantage of this -2 root 2 and also root 2b. So let's see. We threw that to the other side, so which means that I will have 3 minus b plus c as my first term. 3 minus b plus c. I always have a habit of crossing it out. Okay, and then I will have the root 2. Okay, and then I have -2 minus b equal to 0. Okay, so now in this case over here, again, I'm assuming that this is 0, the other is also 0 as well. Okay, so 3 minus b plus c is equal to 0. 2 minus b is 0. So b is equal to 2. If b is equal to 2, c is equal to -1. So my answer, or my equation, will be x squared plus 2x minus 1. And you can solve from there, right? Again, I'm not going to solve the other answer. I want you guys to try it out as well. But then again, this is the crucial part of this question, and how do we do that? All right, so hopefully this summarized everything, and I'll see you guys in the next video.